5.7, number 400. We've got the antiderivative of 1 over 25 plus 16x squared, which again I will write as what I just stated with the dx on the outside to aid in some sort of visual clarity, hopefully. All right, so we have 1 over 25 plus 16x squared. What trig inverse antiderivative, or I should say derivative really, what trig inverse derivative does it look like? It looks like the tan inverse derivative. So therefore the antiderivative of this should be tan inverse in some, some shade or hue of tan inverse. Right? We're comparing it with this. Right? Plus c, of course. All right, so that's the important thing. And we'll compare it with that. So one of the main problems here, it has two problems really. This 25 is not a 1, and 16x squared is not just a single variable squared. Okay? So we're going to concentrate on the 25 first, becoming a 1. That's extremely important, and probably where you should always start. So we're going to factor off 1/25 from the integrand. So 1/25 comes to the outside. When we do that, if 25 comes from 25, we're left with a 1. If 25 comes out of 16, well, 16 doesn't really have a 25 in it, per se, so I should write it as 16 over 25. All right, so now what we need to do is get this expression here to be a single variable squared, which is pretty easy. We did it in a previous problem. We just demand that such is the case. So u squared will equal 16 on 25 x squared, which means pretty clearly that u will be forced to be 4/5 x, and thereby du is 4/5 dx. We don't have a 4/5 dx floating around, we only have dx. So again, move those constants, those multiplicative constants, over to the other side. In this case, is a 5/4. So 5/4 du equals dx. And now we can replace everything. Dx will become 5/4 du, and this will be u squared. We now have the integral all in the variable u. 1 over 1 plus u squared. And again, dx is now 5/4 of du. Move the 5/4 to the outside. The 5 will cancel 25 there. And the 4 will combine with the 5 to be a 20. So we now get 1/20 integral 1 over 1 plus u squared du, but that is exactly the tan inverse structure, right? Just a different letter, and that doesn't matter at all. So this will be 1/20 tan inverse plus c. But u, we know, is 4/5 x, so therefore you need to substitute back in, because the original was in x, we want the final to be in that same variable. So 1/20 tan inverse of 4/5 x plus c is our answer.